Welcome you all to this new lesson of circuit theory. Today we'll be discussing about some numericals on KCL and KVL. In last class, we discussed about Kirchhoff's current law and Kirchhoff's voltage law. Uh, Detailed analysis of those laws were discussed with the help of one simple example. Today we'll be solving some numericals applying those rules which we studied in last class. So before starting this, let me again recapitulate the rules behind KCL and KVL and what are the uses of these rules. KCL and KVL, these two rules together are applied in an electric circuit to get current through a particular branch or voltage across a particular branch. There are some drawbacks of voltage divider and current divider rule. To overcome those drawbacks, we must apply Kirchhoff's current law and voltage law. So what are the drawbacks that we already discussed in last class? You may go through the last class to understand the drawbacks of current divider and voltage divider rules and what are the applications of KCL and KVL. So let us start with this is the topic to be covered today. Let us start with this numerical. Now see, in this numerical, there are multiple sources. There are few resistors. If we are asked to find the current through each branch, so how can we determine that using Kirchhoff's current law and voltage law? For this circuit, we cannot simply apply uh, current divider rule or voltage divider rule. So we must opt for Kirchhoff's current law and voltage law together. So let us start with this solution. This is a given circuit. Now, see, all the terminals are marked here. Here we could consider node A and node D as here we could consider node A and node D as the same node because there is nothing connected between these two nodes, and in basics we already discussed if there is nothing connected between any two nodes, those two nodes will have same potential, and from electrical point of view we could consider those nodes as same node. So A and D node can be considered as the same node. Now potential at this point. So let us omit this A here. Let us put it here. Okay. So the reference node is D. A is omitted from this and A is put over here. You could consider A node here. Now, see, I1 current is flowing through this branch and entering at node B. I2 current is also, as shown, is entering at node B, and I3 current is also entering at node B. Here in this question, the current is mentioned with this direction. In case in a question current direction is not mentioned, you can assume any direction of current as per step 2 of Kirchhoff's law. We discussed few steps which are to be followed to solve a numerical or using KCL KVL. So as per step 2, you can distribute current among all the branches as you wish. Okay. So as all these three currents are entering at the node B, so applying KCL at node B, what can we write? I1 plus I2 plus I3. All incoming currents could be considered as positive. So sum of all the incoming currents should be equals to outgoing currents. So sum of all incoming currents I1 plus I2 plus I3 should be equals to sum of all the outgoing currents. As no current is leaving from point B, So we could say this is equals to 0. Outgoing current equals to 0. So this could be considered as one equation. In next case, let us see, we have three unknowns, I1, I2 and I3. For these three unknowns, we should have three equations to get solution for these three unknowns. So one equation could be obtained from junction B applying KCL at node B. And remaining two equations we could obtain by applying KVL in these two loops. Okay, so let us apply KVL in each loop. So here KVL is applied in A, B, C, D, A loop. That means this A node. So here we are applying KVL in A, B, C, D, A loop. So KVL is applied in the outer loop here. You can consider any two loop. You can consider this loop and this loop, or you can consider the outer loop. So it's up to you. So if we apply KVL in ABCDA loop, what will happen? Let us start with this. What you need to do to apply KVL, first you need to assume direction of travel. So let us assume this is our direction of travel. As I said, assume clockwise direction for your convenience. So we have assumed clockwise direction of travel along the loop ABCDA. So this is your clockwise direction of travel. Now as you are traveling along this path, so for 6 volt, this is clockwise direction of travel. So for 6 volt, this arrow first getting this negative terminal, then it is getting the positive terminal. So along your direction of travel as shown by red, you are first encountering negative terminal of the battery, and then you are getting positive terminal of the battery. So along your direction of travel, you are getting 6 volt, which is having a rise in potential, negative to positive along the direction of travel. So rise in potential, as already discussed, should be considered as plus sign. So this should be plus 6. Okay. Now, similarly, it is also discussed that if direction of travel your travel and direction of current both are in same direction, then IR drop will be considered as negative. So based on that fact, I1 current is flowing. I1 current is flowing in this direction. So through 10 ohm, I1 current is flowing in this direction. And as per direction of travel, see, as per direction of travel, this is clockwise direction of travel. So this is clockwise. So through 10 ohm, current is flowing from A to B, and direction of travel is also from A to B, clockwise direction of travel. So as direction of travel, this is DOT. Direction of travel and direction of current both are in same direction through 10 ohm. So IR drop will be negative. So what should be the magnitude of IR drop? I1 current is flowing through 10 ohm. So 10 ohm into I1 will be voltage drop across 10, and it should be considered as having minus sign, as both the current and DOT are having same direction. Similarly, now let us move to next element along outer loop. So after 10 there is 40 ohm in the outer loop. So what is direction of travel? Direction of travel is clockwise. So this is clockwise direction of travel. So along this 40 ohm current direction of travel is from C to D. See, this is the direction of travel. And direction of current through 40 ohm is from D to C as shown by I3. So here direction of travel and direction of current are in opposite direction for 40 ohm. So if direction of travel and direction of current both are in opposite direction, that implies it should be considered having a positive sign. So magnitude of voltage drop will be 40 into I3. So magnitude of voltage drop is 40 into I3. So I3 can be written as minus of I1 plus I2 based on this equation. So it is simply substituted, I3 is substituted by minus of I1 minus I2 that is equals to 0, and having a positive sign as DOT and direction of current both are in opposite direction. So by simplifying this one, we'll get this equation. So hopefully this, how to get this equation for the outer loop applying KVL is clear to everyone. Next, let us move to the another loop. The second loop could be considered as this one or as this one. So it's up to you which loop you will be considering. So let us consider this loop here, the right loop here. Okay, if we consider the right loop here, you can consider any of these two loops, but here it is considered as the right loop. So again, let us assume this is our direction of travel. For 3 volt, this is your direction of travel. So first you are getting negative terminal, then getting positive terminal. So for 3 volt, there is a rise in potential along your direction of travel. So rise in potential should be considered as plus 3 volt. Again, for 20 ohm, this is your direction of travel. Direction of travel and direction of current, I2. Both are in same direction through 20 ohm. So it should be considered as minus. So minus, and voltage drop will be 20 into I2. 20 into I2. Next for 40 ohm, what will happen? Forty ohm, this is clockwise direction of travel. So for through 40 ohm, direction of travel is in downward direction through 40, that is from C to D, but I3 is flowing from D to C. So these two are in opposite direction, which implies it should be considered as plus sign. Now 40 into I3 will be the voltage drop across 40, but I3 could be substituted by minus of I1 plus I2, that is minus I1 minus I2. So this should be equals to 0 as per KVL. So this is the second equation of KVL. Now remember, this has already been told in last class that while you are assigning sign to EMFs, sign to a battery, you don't need to have any direction of current. You just need to have direction of travel. But while assigning sign of IR drop, voltage drop across any resistor, direction of current should be there and direction of travel should be there. So for assigning sign of EMF, only direction of travel is needed. To assign sign of IR drop or voltage drop across a resistor, direction of current and direction of travel both are necessary. So let us now move to the next slide to solve these equations. So see, here we have three unknowns. So we should have three equations. This one equation, these two are two equations. But here I3 is replaced by this one. So as I3 is replaced by I1 and I2, so I3 is substituted here. So we have only two unknowns in these two equations. So we can solve for these two unknowns to get the solution. So we may apply method of elimination, or we may apply Cramer's rule. Whatever you want to apply, you can. So let us apply Cramer's rule here. So these two are two equations. These two are two equations. As per Cramer's rule, the equations should be written in matrix form. So I1, I2 is there. So coefficient of I1 is 50. Coefficient of I2 is 40. Coefficient of I1 in second equation is 40 and I2 is 60. So this is written in matrix form. So this part and this part, the left hand side of two equations are written in matrix form here. Now I1, I2 equals to, right side there is 6 and 3. So if we make the matrix multiplication, what would be this? 50 I1 plus 40 I2. So 50 I1 plus 40 I2 in first equation equals to 6. In second equation, 40 I1 plus 60 I2. 40 I1 plus 60 I2 equals to 3 in second equation. Okay. So this is how you can get the solution. Now what is D matrix? As discussed earlier, this should be D matrix. This should be the D matrix. Now from this D matrix, 15 into 60, 3000, minus 40 into 40, 1600. So this determinant will be 1400. And how to get D1? While getting D1, this should be replaced by 6 and 3. So in this determinant from D, if we substitute this by 6 and 3, we'll get D1. 50 and 40 is replaced by right side of the matrix equation, that is 6 and 3, which will give us this. And to get D2, this part should be replaced by 6 and 3. So to get D2, this part is replaced by 6 and 3. So finally we'll get these two currents, I1 and I2 are these two currents. Okay. So I2 is negative here, which implies I2 negative means here we have considered I2. Here we have considered I2 in this direction. But as we have got I2 negative, so actual direction of I2 will be in downward direction. So as I said earlier, you can assume any direction of current. If you get negative answer of the current, then your actual direction of current should be opposite to the assumed direction. So here we have assumed I2 in upward direction, but actually I2 should be flowing from B to D. So this is the conclusion of having negative current. Next, what is I3 then? I1 is I1 and I2 are obtained, so I3 will be minus of I1 plus I2. Substitute the values of I1 and I2, you'll get your answer. So this is how you can get the solution using KVL and KCL. Let us now look at this problem. We are asked to obtain all these parameters. So here see, to find Vs, Vs is known to us. Vs is given 1 volt. So Vs is 1 volt. Now to find V1 and V2, this is V1, this is V2, and this is Is. So all these three we need to find first. So see, this is 1 volt, this is 4 ohm, this is 6 ohm. So current through this path will be flowing like this. So what would be IS? R1 and R2 are connected in series because current is flowing through these two paths are same. There is no current getting divided. So IS will be total voltage 1 volt divided by R1 plus R2 total resistance. So IS is obtained as this 0.1. Now if IS is 0.1, voltage across this, that is V1, will be 0.1 into 4. So 0.1 into 4, that is 0.4 volt. Similarly, voltage across this V2 will be 0.6 volt. Next, find IK. What is IK? This is IK. See here, IK is flowing in this direction. Again, there is a current source given which is equals to KV2, where K is mentioned to be 10. So this current source, dependent current source, is having a value of 10 V2. V2 is found to be 0.6. So IK will be KV2, that is 10 V2. So 10 ampere by volt multiplied by 0.6. V2 is 0.6 we have got here. V2 is 0.6. So IK is 0.6 ampere. So IK is found. Next we'll find I3, I4 and V0. So how to find I3, I4 and V0? See, if we apply KCL at this node, IK is leaving, I3 leaving, I4 is also leaving. So applying KVL at this node, what can we write? IK plus I3 plus I4 equals to 0. Okay. Now, how to find I3? See, it's very simple. This voltage is V0. Voltage across I3 is V0. And as I3, R3 and R4 are connected in parallel, so voltage across this is also V0. Okay. Now, how to find V0? This is IK. If this circuit is simplified like this, if this path is simplified, this circuit part is simplified like this. What we did, we combined R3 and R4 in parallel. So this resistance should be 10 parallel 10, that is 10 into 10 divided by 10 plus 10, 5 ohm. So this is parallel combination of R3 and R4. R3 parallel R4. Okay. So if we combine these two in parallel, then the circuit will look like this one. Now see, this current is IK. This current is IK. IK and current through the dependent source should be same. So IK is known to us. Okay. So what should be V0 here? This is V0. So this V0 should be equals to 5 into IK. So V0 can be calculated as 5 ohm into IK. IK means 6. IK is 6. Now, as we have mentioned, I3 and I4 in downward direction, but here IK is in upward direction. So V0 should be minus 30. There should be a minus sign. Okay. Next. So V0 is found. Once V0 is found, this is V0. Voltage across this is V0. So I3 will be V0 by R3. So I3 is V0 by R3, that is minus 3. So actually current should be in this direction. But here shown current I3 is in downward direction. I4 is V0 by R4. that is -3. So my I4 is also should be in this direction. So 3 ampere, 3 ampere together will be 6 ampere, and this will be 6 ampere. So that is how we can get the solution using divider rules or KVL, KCL together. Okay. So this is up to this. In next class, we'll be discussing about network analysis such as mesh analysis and nodal analysis. So as of now, I'm ending up here. Meet you in next class. Thank you all.